Okay,
So
sir.
yeah, so today we are going to discuss the first, second week. All the concept will go through that again, and yeah, and then after we'll wrap up. So first 2 weeks we'll go through, and then if you have any doubt, you can just ask me. Otherwise, we'll go. So this is Vishal, and we already have met like few times. So
Sir, can
today,
we see? Sir, can we see the week to graded assignment, sir? Please. Today.
uh, yeah, so we'll do that. First, we'll go through the whatever the planning that I have made. So we'll first go through the week one and second whole content, and then only I can take any questions. Okay, so see, I can take all the doubts, whatever you have, but we have already TA session. Okay, so TA session is happening daily on the daily basis. You can ask the doubts there also. Like for example, if you have more doubts, so there are some other sessions that have been planned. That is going like that is happening daily on the daily basis. That has been taken care by some TAs so that we have been assigned. Okay, but if I'll be having time,
Sir,
I'll
what are you saying? I can't understand. Sir, session.
Sir, I guess TA sessions is only for foundational level students, sir.
yes. Sir.
Sir, this is not for qualifier.
Okay. So I'll take the questions. So whatever you have in the end after the whole discussion of week one and second. Okay. Then only I can take any questions. Okay. So let's start with the week one. So yeah, and we'll be having the questions in the qualifier on the similar page. Have you went through the mock? Have you wrote the
Yes,
mock?
sir.
Okay, how
Yes,
was
sir.
that?
It was like taking time, and some are easy.
Okay.
Better
So
than graded assignment.
okay, okay. So yeah, so the paper will be on the similar page, similar label of the mock itself. So it's better whatever I am saying. So today's session you can just concentrate, and then I'll be telling you some important portion also that you should be revisiting again and again. Okay. And
So please start, sir.
yeah, okay. Yeah, I'll start. And the graded assign, if somebody has not solved the practice graded, so try to solve it again and again. At least the 4 weeks, whatever the qualifier syllabus is there, you should be practicing all the practice plus graded assignments questions at least twice. Okay, and then only go and write the exam. Okay, so I'll just share my screen.
हाँ मेरे को तावा देना जल्दी से रोटी बना दो मेरे लिए जल्दी से इंतजार मत
Please
करो
mute yourself, everybody.
This is for foundation level, sir.
I told you, right? For both of them, there is a quiz, right? So this is the revision
16,
session for
sir.
what?
On 16 for both there will be exam, sir.
Yeah.
Sir, can you please raise your voice a bit?
Yeah. So it's not audible, or is it audible now?
It's
Yes,
audible, but
sir.
It's okay, sir. It's audible.
Okay. So I'll start with the basic concept. So see, in the week one, okay. So the week one of maths 2, you have like today we are going to
Excuse me,
discuss.
sir.
Yeah.
Sir, is this class only for foundational or qualifiers?
So this is for both. I told you, right?
Sir, can you mute all?
Sure. Okay. So let's start with the week. So today we are going to discuss both the week one and week two. So I'll be discussing whole concept of week one and two. somewhere I'll be telling some of the important concepts that you should be revisiting again and again. So those portions are very important. Okay, and I'll be telling you for the both the weeks, for week 1 also and week 2 also. Okay, so that you should be, maybe you can, while watching the lecture, you can just practice the problems from those portions for sure. Okay, so in the week 1, the concept that we are, so basically some basic concepts also we are going through. So in the week 1 we read about what, first the term is what, the natural number. We read about the natural numbers. Okay, and here in our, so you already are aware of that we are including 0 as a natural number here. Okay, so even don't get confused, why are we taking 0 here or something like that. Okay, because many of the books are having a different, uh, they generally take, some of the books generally takes the 0 as a whole number, some of them takes as a natural number, but here we are taking 0 as a natural number. Okay, so if we have been asked any questions regarding that, so do not mistake there. So 0, we are including 0, so we are including 0 here. Okay, and then you can write the natural numbers like this, like 0, 1, 2 till infinite or whatever you want to. So
why is the 0 is also included in natural number, sir?
this has been discussed, like I guess, so many times. I'm just telling you from the starting itself that 0 has been taken here. So there is a, every time what happens, like many of the teachers generally include 0 as a whole number, many include 0 as a natural number, right? Where here we are including 0 as a natural number. Okay, and that should be there in your mind. That's it. So you should not be asking why again and again. This we have discussed in the starting lecture also, in the first lecture. Then when I took that, we discussed about this natural number, and this is just the convention. Okay, so we are here, we are taking 0 as a natural number. So this is what we have discussed, the basic natural number. If you have been asked any problem from the natural number, count the natural number, how many of them are natural numbers. So wherever you are seeing 0, just count it 0 as a natural number. Okay, don't do the mistake there. Okay, and generally we represent natural number as n. Okay, so these are the basic simple concept that I'm telling you, and then we'll pile up, and then we'll go through the important concepts of the week 1. Okay, and the second one is the integer. So integer, you already are aware of that. Integer, what is integer? Basically, if you are taking all the negative plus positive, all the values, so we'll start with some minus infinity, -2, -1, and 0, and then 1, 2. So these are the integers, and you already are aware of that. I hope so. You are already aware of that we represent integer as z. Okay, so what are the other number that we have, and we can do all the arithmetic operation on this natural number. Okay, and here in the lecture what we read, we just read the basic concept. This all stuffs are very simple, and I hope so everyone is aware of this. Addition, we read about this, addition, subtraction, and this multiplication and the division. These are pretty simple division we have discussed, right? And also we have discussed about the modulo also, correct? And what does modulo gives you? If you have been asked, modulo generally gives you the remainder.
Reminder.
Yeah, so if you have like 10 mod 3, you'll be getting 1. Okay, so whenever you have been asked something like that, like which of the following statements are correct, and then you have been given the statements, so you should be marking whenever there is a mod that gives you remainder. So whenever you divide this 10 with 3, you'll get some remainder, and this mod will give you the remainder only. So this will give you the remainder value. Okay, and then there is some, we read about the factors. Okay, if you are getting, if a mod b is equals to 0, that means what? That means you are getting remainder as what? Remainder is 0. Correct?
Yes, sir.
Yes, sir.
Yeah. So A mod B means A mod B is equals to 0 means you are getting the remainder as 0. That means B is dividing the A. Okay. So let's, for example,
So
B.
how will we write it in the sign language, like with the vertical line, A mod B?
You can write A mod B like C. Generally, you write like this. Okay. See, A mod B means what? Tell me first. A mod B means what?
Sir, B vertical
by
line
A.
A.
B is divisible by A.
When A
B-
divided by B, the remainder is 0.
What?
When A divided by B, the remainder is 0. In this case.
B is a factor of
A by
A.
B. So
B is multiple of A.
A is
See, if you are writing 6 mod 2 equals to 0, that means what?
2 is a factor of 6.
2 is a factor of 6.
6 is multiple of
6 is multiple of 2. Okay, and you write it like this 2. So every time this will be smaller and this will be bigger. Okay, in this way you just represent it. Okay, is this clear?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
yeah. Let's move to the rational number. This is in the form of some P by Q. Correct? Where P and
So
Q
what
are
is the small and big? Excuse me, sir.
what?
Yeah, small and big.
Yeah, so this way we represent A by B. A is bit smaller
Mod
and the
use.
B is a bigger. Huh?
This mod. This sign is shows mod sign.
No, not sign. I'm just telling you, just if somebody is getting confused, how generally you write this. This is what I told. Ki A is generally small and B is the bigger one, the bigger
So why
number.
we write this? Why we write this?
So this is the comprehension. This is how we write. See, I'll show
So
you.
why we write this?
Okay, so I'll show you. So in which lecture this has been discussed? The first lecture, right?
yes,
Sir, in the first lecture, sir.
Okay, so see, whenever see A divides B is what? If A is a number that divides B, generally how we write it? B mod A equals to 0. B mod A equals to 0, that means we are getting the remainder as 0. Means A is dividing this B. Correct? And this is how we represent it. A divides B. Okay, and A is the smaller number.
Yes,
And B
sir.
is the bigger number. So this is just the way to represent it. There's nothing. Okay, got it?
Yes, sir. Yes, sir.
Okay, so rational number, you can write it in the form of P by Q, where P and Q are what? Integers. Correct? And you represent rational number as what?
Q, sir.
Right?
Sir.
Okay, and the representation of rational number may not be unique also. Like let's, for example, 1 by 2 can be written as what? 2 by 4 can be written as 10 by 20. Right? Correct? So the number is not
Yes, sir.
unique. Okay, and the reduced form of any rational number P by Q is when P by Q is the reduced form P by Q is when P by Q has no factor in common.
Except one, sir.
One.
Okay.
GCD one.
Yeah. And you can write this, the GCD of P Q is equals to 1. GCD is the greatest common divisor of P and Q is 1.
Sir, if the number is completely divisible by the sir, if the company is sir, hello, sir.
Yeah,
Sir,
yeah,
if
yeah.
a number is completely converted to, into the reduced form, or we can complete the complete the, I can say finally find the GCD of P and Q, then only it is known as a reduced form. I mean rational number, or so 10 by 20 is rational number, or 1 by 2, or both are rational numbers.
Both are rational number, but 1 by 2 is the reduced form of 10 by 20. Okay,
So
because
so we need to reduce it every time. Like if there is 15 by 30, then it will be 1 by 2. So
see,
what
15, yeah, okay. So 15
Sir,
by
what
30
is
is
it by GCD, sir?
okay. 1 second. I'll tell you GCD. First, I'm telling you 15 by 30 if it's a written. So what did I told you about the rational number? Rational number is what that can be written, that is written in the form of P by Q, and P and Q are the integers. So here if you will see 15 upon 30, both of P by it is written in the form of P by Q and both are integers. That means this is also a rational number. But if you want to reduce it, so there is a reduced form of rational number I told you, where it can be reduced. So it can be reduced in such a way 1 by 2, in such a way that the GCD of the reduced form is equals to 1. The GCD of the reduced form is equals to 1. So for if you'll see that for 15 and 30, what is the greatest common divisor? 15, right? But it should be 1 to in the reduced form. For 1 and 2, it is 1. The GCD of 1 and 2 is what? 1. So that's why 1 upon 2 is the reduced form of that 15 upon 30. Correct? Is it clear?
Yes, sir.
Yes.
Yeah. Okay. And so what is GCD? Somebody asked. So GCD is what?
Greatest common divisor.
Yeah. So greatest common divisor. Okay. Basically, the greatest common divisor. Yeah.
Sir, I just wanted to clear that, like in qualifier exam, till which week content is coming?
Till week 4.
Till week 4?
Yeah.
Okay, thank you.
Okay. So the greatest common divisor of two non-zero non-integer P by Q is the greatest positive integer case, such that K is the divisor of both P and Q. Let's, for example, you have P as 15 and Q as 30. So what is the greatest common divisor of this 15? So what is that number that will divide 15 also and 30 also? So there can
15, 10 3 30.
5 also can be there, 3 can be there, 15 also can be there. But we need to find it the greatest one. So which is the greatest? The 15th is the greatest. So that's why for GCD of 15th and 630 is what? 15. Okay. Yeah. So similarly for 15 and 45, it would be 15. Right?
Yes, sir.
Okay.
Yes, sir.
Yeah.
Yes,
so GCD is clear. So let's move to the after the rational number. We
Sir, a doubt.
Yeah, go ahead.
Is subtraction and subtraction the same thing?
What subtraction and
subtraction?
Subtraction and what is the other one?
Subtraction. SUBSTRA.
Hey, this word I didn't heard of. Like this, we already know, but this is something different.
Sir, in the textbook it was given
That
as
is giving the value and substituting the value. So if x equals to 15, we are going to substitute x equals to 15 in the given equation. That is what subtraction means.
Oh, okay.
Yeah.
Same like substitution.
Okay, so see, there can be some typo error, but subtraction is simply the that you have like read from the childhood, right? There's nothing about subtraction, but I need to check it.
Yes, sir. Because
Okay,
it was
but-
given like that in the textbook, I got confused.
Okay, but don't get confused. Like there won't be any such like subtraction.
Yes, sir.
Yeah.
Yes, sir.
Okay. There may be a
Sir,
typo.
can
Or,
I know that root 2 and root 3 are rational or irrational? Because it is confusing for me.
okay. I'll just go through the irrational number. So we have done with the rational. So we are now with the irrational. So irrational numbers are those numbers that can't be written in the form of p by q, and where p and q are the integers. Okay, this is the simplest definition of the irrational number. See, we have, like, for example, so the examples of irrational can be like
Root 2.
yeah, square root of any integer
Root 2.
that is not a perfect square. Yeah, root 2, root 3.
I.
No. Iota is not a irrational number.
Imaginary number.
Iota is imaginary.
It's a complex number, sir.
Yeah.
Yes, sir. Can you explain complex number?
Complex number, you don't have to read the complex number here. And so complex number is generally which are not the real number. So complex number are mostly the imaginary number that you'll be reading in upcoming courses. Okay, so here for now.
One request.
Yeah.
Sir, can you also give the set representative of the each of the type of numbers, like real number stands for capital R, things like that?
Yeah, I told you, no, for rational number till now I am giving for all. Rational number I told you Q is there, right? For integer I told you Z is there. And then for the natural number N is there, right? So I'm giving you for all the numbers. Okay. Now, so see, basically the irrational number, you can just assume whichever the number are not rational, you can just tell that as a irrational number. Okay, in the real. So real is what? The real number, whole real number is what? Rational plus
Irrational.
irrational
number.
Sir, are not we going to check terminating or non-terminating and
yeah,
then
no.
Sir, you mean that all the decimal numbers are irrational, am I right?
What?
Sir, all the decimal numbers, for example, 1.5, that are all irrational, right?
No. 1.5, see, you can write this 1.5 is what? 1.5 you can write in the, see, rational number of what? That you can write in the form of p by q, where p and q is an integer, some integer. 1.5 you can write, right? 1.5 you can write like 15 upon 10 or maybe 3 upon 2 is the reduced form. So this is a rational number.
Also, we can square root, sir. Square root.
See, irrational number, the examples I can give you, all the square root of a none, those are like not perfect square. It's for example, root of 5, root of 6, root of 7.
Cube
So
root
this is
of
the
5.
root of?
Cube root.
Excuse me, sir.
Yeah.
Sir, can I ask question?
Yeah, you can ask. So here we are discussing about the rational
Yeah,
and irrational.
yes, sir, yes, sir.
Yeah.
Sir, if in question give 1.5 is rational or irrational, sir, what can I?
See, I told you, na, if you have any number that you can write in the form of p by q, where p and q are integers that are rational number. If this is like, for example, this is 1.5. 1.5, can you write it like this 3 by 2? Or
Yeah,
just
yes, sir.
remove this dot and can you write it like 15 upon 10? So this is what is in the form of p by q or not, where p is 15 and q is 10, and those are integers, right? So this is a rational number. I told you irrational numbers are those one, mostly if you asked about the irrational number, I gave you the set of numbers. Those only most probably will be asked. What about the pi, e, or the square root of any integers? Those are not perfect square. Okay, let's for example root 2, root 3. Okay, tell me root 4 will be there or not?
Not.
No,
sir.
no,
sir.
no,
sir.
because 4 is a perfect square. Yeah, so root of 4 will be, you'll be getting 2. So this is not a rational number. Okay, this is not a irrational number because 2 is a rational number. You can write 2 upon 1 in the form of p by q, and p and q both are integers. So you can write it in this form. So this is a rational number. But except that, wherever you are getting the square root of a non like perfect square number, will be getting a irrational number. Okay, so this you can just if you are getting confused, you can just simply remember pi is plus like or the square root of all the integers. Those are not perfect square. Okay, those are the mostly irrational number. And here also, if you are getting any questions regarding counting of irrational number, something like that, mostly you'll be getting questions such that you have like count the rational number. If you are getting, so you'll be giving like 1.5, 3.5, 1.75, 1.25, 5, root 2. So how many of them are rational?
4.
4, correct? Because
Four,
this
sir.
all, this you can write in the form of
Yes, sir. P by
Yes,
Q
sir.
form, sir. P by
yeah, this
35.
you can write it like this.
1.75 is 175 by 100, 1.25 is 125 by 100.
Correct. So you can write in the form of rational number, P by Q form. So those are like rational
Sir,
number.
I have a question.
Yeah.
Hello.
Yeah,
Sir,
yeah, go ahead.
minus root 4 is a rational number?
Yeah.
Sir, but root 2 can also be written as 1.43, right, sir?
What? You asked for -4. -4, you can write it
No,
like
no.
this, right? What?
No,
Sir,
sir,
you can
I
write
will ask minus root 4.
Okay, this one.
Yes, sir.
This we have one read now. I told you, right? This is a complex number.
Imaginary number.
So
Right?
one
This we
question.
didn't read. So
Sir,
negative of
root 2
any.
can be represented as 1.44.
Yes,
Then it can also be represented rationally.
This is not 1.44. This is not the exact value. It is the
approximate value.
Sir, can you explain the rationalization process?
Why not pi?
See, whatever we are not reading here, that are not going to ask, that is not going to be asked in the exam. Okay.
Sir, but in graded assignment, there was question we have to solve with rationalization.
Okay, I'll go through that questions. Okay, and I'll tell you without that also how we'll be solving. Okay.
Sir, for the exam, sir, will there be multiple choice questions?
Yeah, so you can have any type of question, MCQ, MSQ, or NAT. So all the three type of questions can be there, where one of the four is correct, many of the four is correct, like one can be correct, 2, 3, 4, and NAT is means you have to write enter the value. Okay.
So how many questions?
Approximately how many questions will get?
I mean, like J pattern.
And the number of questions will be like something between 15 to 18. Okay.
Sir.
Okay, sir.
Sir, please continue, sir, with the class.
Yeah. So I have discussed. So see, we have to complete it everything under 2 hours itself. So by 10 we have to finish everything. So till rational number I discuss. Irrational. So real number is what? Real is simply the rational plus all the irrational number. Okay,
Yes,
and
sir.
I told you what are the irrational number that you should be having in your mind. Okay, except that there won't be like most probably there won't be any questions. Okay, I told you whatever the irrational number I told you that should be there in your mind.
Sir,
Yeah.
can you please tell me how which topic you have cleared till now? Which topic you have cleared till now?
Yeah, till now from the starting all natural number, basic concept we have discussed till irrational number we have discussed. Okay, now we are moving into
natural number and irrational number.
Natural number, integers, rational, irrational, real, all we have discussed. Now we are moving to the set.
Okay, sir. Okay.
So we are moving to the set. Okay. So set is simply a collection of
Sir?
well-defined items.
Hello, sir.
Yeah.
Sir, can you tell me why 2.999 is not an irrational number? 2.999 and so on. Like 9 is repeating n number of times. And why it is not an irrational number?
Why this is not a irrational number?
Yes, sir.
So you see, first of all, so if you have been, so did you get any type of questions recurring or terminating number? Have we discussed about this? if we are discussing this all concept that has not been taught, so it's not beneficial for you in the exam. Okay.
Sir, are you gonna cover
Some of the questions by
in
not
graded assignment.
sir, are you gonna cover
See.
all the 4 weeks?
Yeah, so I'm going to cover all the week 1 and 2, and then after you can ask your doubts. Okay. Otherwise, it will be going to take a
Right,
lot
sir.
of
Right,
time.
sir.
Okay, sir.
Okay.
Yeah.
So
So
root 8 is a rational or irrational?
I told you root of any integer, those are not perfect square, are irrational number. Okay, this is irrational.
Yes.
Why are you getting confused? I don't know why. Like whatever has been taught here in the lecture, I told you in one bracket itself, rational and irrational number. So whatever, so rational, anything that can be written in the form of p by q, where p is an integer and q is an integer. Irrational number, except this number. Okay, and irrational, I told you the examples also, those should be there in your mind. The like pi, whatever we have discussed till now, pi e, and the square root of all the integers which are not perfect square. Except this will not be, most probably will not be getting any questions. Okay.
Yes.
Yes, sir. Yes, sir.
Sets are simply the collection of all well-defined items. Okay, and in this set there is like order is not required. So you can have any set, something like A, B, and you can have this BA, and both the sets are same. Okay, so the order is not important here. Okay, so let's, for example, a set of, if we have been asked to write the set of a natural number less than 10, so you can directly write from 0 to 9.
9.
Correct. So set of all month or set of all the weeks of, so you can write it. It is simple, like sets a theory. Infinite sets are what? Like infinite set, we have been asked to, okay, write the, what is the set of all even natural number. Okay, or the set of all integers. So those are like what? Infinite numbers, right? So that's why it's the infinite set. But these are finite sets. So there can be like what? Set can be what? Finite. Finite, where the cardinality you are already aware of. Cardinality is the number of elements in the set. Okay, so finite set is, if you have been asked to write the, like the set of all natural number less than 9. Okay, or the set of natural number between 10 to 15. So there you can write there the sets are finite, because you can count the number.
Yes, sir.
Okay,
Count
and
the
if you
elements. Yes, sir.
and if you have infinite, that means you have been asked directly set of all natural numbers. So that will start from 0 to infinite. Set of all positive natural numbers. So that will also start from some 0 to infinite. Or if you are including 0 as a even number, that is fine. Otherwise, from 2 to infinite. Okay. So all the items that is there in the set is generally known as element. Order is not important for this, and duplicate in the set doesn't matter. If you have something like A, B, A, so this is similar to what? AB. Okay, so the duplicate in a set doesn't matter. This was, and now I told you about the number of elements. So whatever the number of elements is there, number of elements in the set is known as the cardinality. And this is an important one. So
Sir,
from the
can you please
starting,
tell me again finite and infinite? There was
okay.
a network issue, sir. Can you please repeat?
Okay, I'll tell you. So see, finite is those set where you can count the number of elements of that set. Infinite set is that set where you can't count the number, the cardinality you can't count. But for the finite set, you can count the cardinality. Okay, that's the difference between finite set and non-infinite set. Okay, and this is one of the important topics. So the first important stuff I told you, right?
Sir,
This is the one of the
cardinality mean?
Can you
cardinality
repeat
is the
again?
okay. So the cardinality of the set is the number of element in the set S. Okay, so there is some set S. So there must be some number of the element, right? Let, for example, this is A, B, C. Correct. So what is the cardinality of this? 3. Correct.
3.
Right. Yeah, and this is one of the important portions. So you should be
So
revising
what will
this
be the
topic.
cardinality of the second set? 3 or 2?
For which portion?
So this set A, B,
So
A.
if one element is repeating, so what is cardinal?
What? Cardinality of?
Sir, what is the cardinality of that A, B, and A?
2, right, sir?
Okay. So here, so what's the number here? Number of element in this? So
3.
different number of elements.
3.
How many different number of elements are there?
2.
2, sir. 2.
Yeah.
Two, sir.
Yeah. So that should be the cardinality of the set. Okay. So and this is the one of the important portion. Okay.
Sir,
So you have
cardinality is counting the number of elements in the set. Am I right, sir?
yeah, correct.
Okay, sir.
Okay. So now we'll discuss the if you have known about this now the subset.
Excuse me, sir. So what is cardinality? 2 or 3?
I told you, no, 2.
Okay, sir.
Excuse me, sir.
Yeah.
Means which is repeating that it will be not counted.
Yeah.
Okay.
Okay. So for the subset, what is subset? A set X is a subset of another set Y if element of every element of X is also the element of
Y.
Y, right? And how do we represent that? X is a subset of
Y, sir.
correct?
Yes, sir.
Sir.
Okay. If you let's for example, if you have a X as a subset 1, 2, 5, 7, 9, 300, and Y is what? 0, 1, 2, 5, 7, 9, 40, 170, 300. So that means what? X is a subset of Y, right? Why? Because
Yes.
all the elements of X is there in Y also, right? So that's why X is a subset of Y. Similarly, if let's for example, if you have X as 4, 16, 32, and 64, and Y is what? Y is 64, 16, 32, and 4. So tell me whether X is a subset of Y or not.
Yes, sir.
So both are equal sets.
Yes, sir. Yes. 64, 16, and 34.
Y is also subset of
Sir,
X.
both X is subset of Y and Y is subset of X.
Yeah.
Yeah,
Equal.
correct.
And both are equal also.
Sir, if any
Yeah.
one match, then it will be subset of X will be subset of Y. If any one matches.
If any one matches, means all the elements should
There's
be
nothing
there
other
in Y.
elements, sir. So it is not
Sir,
subset.
it is
It's only
proper
equal
subset.
subset, sir. It is only equal set, sir. X
See.
equal to Y, sir.
All the element of X is there in Y. Then only you can say. So I want the definition I told you. A set X is a subset of another set Y if every element of X is also in the element of Y. Then only X is a subset of Y. See, this both set are equal. So you can write anyway. X is a subset of Y. Y is a subset of X. X equals to Y because both are same set. Right? I already
Yes,
told
sir.
you
Then
that
it is a
order
proper
doesn't
subset.
matter in the set.
So, but in the first example, it should not be equal, right?
The first example is not equal. X is just the subset of Y. In this case, X is not equals to Y. Okay.
Okay,
sir.
Yeah. So, and now we are discussing the proper subset. So, proper subset.
Sir,
set
first
X.
one is not a subset of Y. X is not a subset of Y.
No, X is a subset of Y. I told you.
But
No?
X is not equal to Y.
X is not equals to Y. That is fine. But X is a subset of Y. All the element of
Yeah.
X is there in Y, right? So that's why
So
X is
it's
a
not a
subset of
proper
Y.
subset, right?
That is not a proper subset that you can say. See, X.
Sir,
See.
can you please scroll up for 1 second?
Okay.
Okay, sir. Thank you, sir.
Yeah. So a set X is a proper subset of another set Y if X is a subset of Y, but X is not equals to Y. And how do we denote this? This like this. This is X is a proper subset of Y. Okay. So let's, for example, the first example. So the first example is what? X is a subset of Y, but X is not equal to Y, right? So we can represent X as a proper subset of Y,
subset.
Got it, sir.
right? But in the second case, both are equals. So can you say that X is a proper subset of Y?
No.
No.
No,
sir.
You can't say
Correct.
that properly.
Because X is equal to Y.
Correct. So we have discussed the proper subset. So you are already aware of that. Now we have discussed proper. So these three concepts that I told you are important. So whatever I told you, set, subset, and the proper subset.
Sir, can you repeat what is proper subset again, sir? There was a
sir.
network.
Okay. So the proper subset is if so I'll just write it, if set X is a proper subset of another set Y, if X is a subset of Y, but X is not equals to Y. Okay. Is it clear? X
Yes,
is a
sir.
subset of Y, but X is not. Like for example, the first example I told you, X is equals to this one Y. So X is a subset of Y because all the element of X is there in the Y, but both are not equal. So that's why X is a proper subset of Y. But in the second case, all the element of X is there in the Y, but both are equal. So that's why it's not a proper subset.
Sir,
Yeah.
what will be the representation?
What will be the representation of what?
Yeah, X subset of Y. How can we write?
I told you, no, this way.
What will be the symbol?
Yeah,
Okay,
this thing. Okay.
There will be no equal to.
Yeah, there won't be any because X is not X can't be equals to Y, right?
Excuse me, sir.
Yeah.
One more symbol. It was discussed in lecture, sir. Cutting the equal to symbol in the subset.
Yes.
Improper. So is it that is
Both
also
are
there,
same.
sir, for proper
Yeah,
subset?
yeah, both are same.
Sir,
This
in it is a proper subset.
wait a second. I'll just open that. This is what you were saying, or something else. This is what you were saying, right? So in both
Yes, sir,
way you
yes,
can
yes,
represent.
yes.
Yeah, the notation is same.
So that is also for proper subset, no?
Yeah, that is also for proper subset.
Okay, sir. Thank you.
Okay. Any other questions you have?
Sir, can you ask something?
Can you?
Sir, as X is a proper subset of Y, so can we write it in reverse like Y is a subset of X because they both are not equal?
No, we can't.
Can you repeat this?
Sir, as
X
I've written, X is a proper subset of Y. So can we write that Y is a proper subset of X?
No, you can't write. Because can you see this? All the element of Y is there in X? No, right? So how can you write that? I told you the first statement should be fulfilled. If X is a subset of Y means each and every element of X should be there in Y. Okay, and the vice versa, the opposite you can't write because you can see this Y is a bigger set, right? All the element of Y is not there in X, so that you can't write. Okay, if both the set are equal, then you can write X is a subset of Y and Y is also a subset of X. If both are same.
Proper subset, sir.
I'll tell you again once more, don't get
Sir, if
confused.
both are same, then it will be not proper subset, right, sir?
Yeah, if both are same, then those are not proper subset, but you can write it like both are subset of each other. If both are same, like for example, this X and Y are same, right? So we can write it X is a subset of Y and Y is a subset of X, right? That we can write, but we can't write X is a proper subset of Y because X and Y are same. That's why. So this is the one, the proper.
So
that's the-
both are subset of each other.
both are subset of each other. Yeah.
Sir, what if elements are same but they repeat themselves? There is repetition in them.
That is not going to make any difference. I told you, in the set, if you have a two number, the duplication we are removing, right? Duplicates in a set doesn't matter. I told you, order is
Okay,
not important and duplicate in a set doesn't matter. Okay?
Okay,
Yes,
sir.
sir.
Yeah.
Sir, if X has only one element, which is from Y, so is X is a subset of Y?
No. Only
So
one
every
element. I
element of
told you,
Y should be an X.
each
Sir,
and
please, you can go ahead, sir. Doubt we can clear later.
yeah. So I will tell you one last time that each a set X is a subset of another set Y if every element, that's every word is there, every element in X is also an element in Y. Then only you can say X is a subset of Y. Okay? Let's move to the other part. Otherwise, we'll
Yes,
get
sir.
stuck there. Okay.
Sir,
So
would you
this,
mind, sir, would
this
you
set,
mind to make difference between subset and belongs to?
not subset and yeah, belongs to is a different, like belongs to, let's for example, you have
Part
any
of it.
number, let's for example a natural number, and you can have a smaller set and you can say whether this belongs to. So see, belongs to is simply the way that you represent in maths, that for example a belongs to some natural number, that means a is some value that is coming from this generator. Okay, so that is like that a is some number that belongs to, whenever you are taking out a, that is coming out from the natural number.
Subset.
So this is simply
For once.
yeah, correct. Let's move to the state comprehension. How generally you generate this? Okay, so the set comprehension is what? Is a construction of a subset from the existing sets like natural number, integer, real number, etc. by applying some filter on every on every element in the existing set. It is built with what? Three components, and they are what? Generator, filter, and transformer.
Transformer.
Okay. Let's for example, you have to write what? Squares of all even integers. Okay. So first, what we generally write? We generally write the transformer. So we have to first transform. So what should be in the form of? So is this square of all even integers. So this should be the transformation should be what? X square, right? And from where those data points should be coming? So this should be coming from integer. So X should belongs to what? Integer, comma, and filter. Filter we need to put, right? A square of all even. So this is putting some like we are filtering the data from the integer number. So first we did transformer. We first
Sir, what is the symbol between X and Z?
What symbol between
X and Z? Yes, sir. After
belongs
X,
belongs to X belongs to Z.
Okay.
So whatever the number, because X square of all even integers. Integer is what? Z, right? So we are taking out some value X because we are transforming. We are doing the square of that number. So that X. Please mute, like everybody. Please mute yourself. Yeah. X belongs to Z, and then we have to do a filtration of the data points. For the even number, what we can write is X mod of 2 equals to 0, right? X mod 2 means 0 means whenever the number is getting divided with 2, we are getting the remainder 0, right? That means that number is getting divided by 2. Okay, so this is how we generate, we write. Okay, got it?
Yes, sir.
Yes.
Yeah. So this is, so generally we have what? We have three things. We have transformer, we have generator, and this is the filter that we put.
Sir, give an example, sir.
Gave you an example, square of all even integers. Square of all even integers. How will you write?
So do we need
first-
to do this furthermore, or just this is enough?
So this is, see, you can get a question like, you can be written like this is a question. This is a question, and then you can be given 4 options. Which of the following is the correct comprehension? How will you write that? So this, then you can be given 4 options, 1, 2, 3, 4, and then you have to mark which of the following is the correct. So whatever it's been written here, like square means you are doing the transformation of all the data points, and from where it is coming from, integer. So whatever the word that has been written, from there itself you can get the idea. Okay.
Okay. Sir, take another example, sir.
Okay, so I'll just take it from the lecture itself. So what has been taken here in the lecture? Okay, so let's we have an example, the subset of even integer. Even integer. So the earlier I took for the square of the even integers. Here it is just the even integer. Okay, so the even integer. So the first, the transformation should be what? X only, because we are just taking out the data itself. The second should be what? From where we are. What is the generator? From where we are taking out the data. That is integer. And what is the condition that has been kept? It should be even. So x mod of 2 should be equals to 0, right? For the even, what can we do? The filtration. The filtration can be that number if we are dividing with 2. And if this was odd, what you would have written? If this was odd, what you would have written? If this was odd.
X mod 2 is equal to 1.
Correct.
X is not divided by 2.
Correct. So this is what we will write. Okay.
Sir, what will we represent the dashed line, sir?
Dash line. See, this we are just representing x from where we see this is the just the separator of the transformer, the data that we are transforming, and the generator. It's just the separate. We are just separating the data. That's it. Okay.
Yes.
Yeah. So now
from the Russell's paradox, actually.
Okay, so those are like I told you, like those will not be asked in the exam. So whatever is important for the exam, I'm discussing those. Okay, and I don't think so that those topics are just
Sir, can you show the generator and filter, sir, please?
What? For your curiosity purposes, sir has told those.
Sir, can you show the generator and filter, sir?
So this is the example we were having, square of all even integers. The generator is only those data, like data from where, what?
From which week?
From which?
Weeks.
Oh, this one. These are for week 1 only, right? These are for week 1 only we are discussing, and then we'll go to the week. So first we are discussing. So I was discussing transformer, generator, filter. I guess this is clear to everyone, right?
So what would be the filter for prime numbers?
What the filter for prime number? So that you need to like the filter for, because there is no pattern in the prime number, so that you can't write.
We cannot represent prime numbers.
So, no, you can write it like this. Yeah, you can write it that, see, 2 numbers, see, in the pair you can write. See, or in the pair or any numbers. So what are the prime number that you generally write? What is the prime number?
Which are not divisible by any other numbers.
Yeah, so which are generally,
Yeah,
which are generally factors as what? Factors as
1 and itself.
Factors as 1 and its own.
Themselves.
The number itself. Correct?
We can tell GCD.
Yeah, so you can write. Yeah. So sorry, like I thought there is no pattern, so you can write, but you can write the prime number also, where you have the factors can be what? 1 and itself. Correct or not?
Yes, sir.
Yeah.
Yes, sir.
So see, this till now, all the, like, see, in the exam will not be getting much of the questions till this point. Most of the questions, whatever you'll be getting, will be from the topics that I'll discuss from here itself. Okay, so this were just the basic concept. Most of the problem will not be like, there will be some questions, but the higher weightage of the topics I'll be discussing it now. Okay, and what are those portions? The very
From
important
week one, right, sir?
Yeah, from the week one. See, set is very important. You must be expecting, so there will be questions from set theory, proper set, and then cardinality. Those portions will be there. Union, intersection, all will be there. The set is very important portion, and the other important portion is what? The relation.
Sir, can you please show in the graded assignment or practice assignment those questions of set?
First clear the concept, sir, about relation.
Yeah.
Sir, I'm just asking, sir, the type of questions, sir, you have said just now.
Okay, so I'll
Not
just
so
show you
expensive.
once. Okay, let's, for example, you have some questions.
Sir, the type of questions that are asked in this test will be like in the form of like practice assignments, graded assignments, and mocks.
Correct. Yeah.
I mean,
Will be
he can
similar
follow
to-
just that.
Yeah. So yeah,
That is
you
the
can
same
follow.
pattern.
Yeah, it will be similar to that. So whatever the mock you have or the practice or the graded is there now, it will be similar to that.
Yeah.
So you
We
should
can
practice
move on,
those
sir.
questions.
Sir,
Exam.
we have not covered even one
It's
week,
already
sir.
9, sir.
Yeah, that's what. So we can move on, sir.
Yes, sir.
Yes,
Okay.
sir.
So I'll just discuss all the concept and then we'll see the doubts. Okay. No. So okay. So now we have to discuss the relation. Okay. So basically, see, this is important. So I'm giving 5-star for this. So from here, all the topics are pretty important.
Sir, if possible, can you mute everyone so that we can just listen to you?
Yes, sir, do that.
So everyone, please mute yours. Like I can mute, but they can unmute from there itself. Like, so it's better you yourself mute.
Excuse me, sir.
Yeah.
Is it important to discuss superset and superset and empty set?
Okay. See.
Is it important? If it is important.
Yeah. See, you already empty set is what that doesn't have any element, correct? Empty set, there is nothing available. Okay. So this is an empty set.
Sorry, is empty set is a proper subset of set?
Yeah. So what happens? The phi generally what happens whenever you are writing the power set, okay, or the subset of a power. Whenever you are writing a power set of a set, so what happens? There will be getting this phi, okay. But if you have been asked how many elements are there in the empty set, that means there it is 0. There is no element, okay. But if you have been asked regarding the phi, because let's for example you have A and B, so how many power set in the power set? What should be the cardinality of the power set for this A and B?
2. So that would be A, B, and an empty set. A, B.
Correct. One will be
Sir,
what? One will be phi,
C.
and one will be A, one will be B, and one will be AB.
Set of AB. Yeah.
Correct. So it will be 4. So wherever the number, whatever the number of the set is, like, and you can just
2 to the power n.
formula 2 to the power n. Okay, and this is the formula that you should be using. But if you have been asked how many number of elements there in the empty set, that means 0. Okay, this is what you'll be. If you have been asked, you will be asked regarding the number of this. This is a bit confusing, so that can be asked. Okay, so let's start with the relation now.
Sir, I have a question, sir.
Yeah.
So is an empty set a subset of every set?
Yeah, empty set is a subset of every set. Okay. So
my question is, this empty set is a subset of not subset. What we proper subset
But empty set is proper subset is a different concept.
Proper subset. I got, sir. If only empty set is there, then it is it that a proper subset?
This is a subset. That means, yeah, for every set. Because there is nothing available there, right? So nothing means that it will be that nothing is there in every set, right? Proper subset is what I told you, X belongs to Y and X is not equals to Y. Then only this is a proper subset, right? This is what I told you. If you have a phi, the empty set, that means what? That will not be equals to Y for sure, because Y has something, correct? So if Y has something, that means what? It can be proper subset. Got it or not? Did you get the idea?
Yes.
Yeah. Okay. Yeah, and one more thing, I guess I left it. Union intersection, you already are aware of that. So that is not required to discuss, right? Union, you already know. Union
Yes,
and
sir.
intersection.
Sir, we know, sir.
Yes,
Sir,
yes.
sir, we know, sir.
Yes,
Union,
sir, we know.
intersection, complement, De Morgan's law, all those things. Yeah.
Okay. So yeah. So okay. So intersection generally is you have to, let's for example, if this is A and this is B, this is the area of the intersection. But union is what? The whole area. So this area itself, this area also, and this area also. Okay. This is basically or that generally you use for the intersection, and it should be there in both intersection, or for union it can be A or B. It is there in A or it is in there in B. So that is the union. Okay. Yeah. So let's start with this Cartesian plot, Cartesian product. So the Cartesian product of any two non-empty set X and Y is defined as the set of all possible ordered pair XY such that X belongs to X and Y belongs to Y. Let's for example, you have some non-empty set X and Y. Okay. And then you have been asked to create all the possible ordered pair of X and Y such that X belongs to X and Y belongs to Y. So the Cartesian product is what? X cross, this is X cross Y.
Why, sir?
Yeah. And if you have been given X as A comma B and Y you have been given as 1, 2, 3. So this is also in the curly bracket itself. So what's the difference between curly and open bracket?
Curly bracket represent elements and normal brackets represent intervals.
Oh, yeah. So there is a difference between always. So if this is open bracket or close bracket, so A comma B means the value is from A and B, but that is not including A and B. But if this is A, B, that means it is including A and B.
The endpoints are included.
And if this is curly bracket, that means only A and B. Okay, so I told you here, if I have X as a set with A, B as an element and Y as a set as 1, 2, 3 as an element, then the Cartesian product of X cross Y is what? A1,
A2, A3.
Yeah, so you can write it
B1,
like this. So this
B2,
is simply
B3.
correct. So, and the number of element that you'll be getting is 2 into 3, that will be 6. Correct?
Yes, sir.
So this is what? This is a simple relation between two. Yeah, so this is simply a relation between two sets X and Y. Correct? A relation between two sets.
There will be B1, B2, B3, right?
Yeah,
Yes,
there will be. I just like I didn't wrote B1, B2, B3 will be there. That also will be there. Okay,
Sir,
so
can you please scroll up a bit? I have a doubt there.
Yeah.
Just more little.
Yeah.
Hi, here. In bracket, you wrote the condition of proper subset. I couldn't hear it properly. Why did you write it?
I just wrote it. There was some confusion. Somebody was asking between difference between proper subset and subset. So the subset is simple, like x. All the every element of x should be there in y. For the proper subset, that x should not be equals to y.
Yes,
Right?
sir.
Yeah, this is what I do.
Yeah, this is
Excuse me,
YouTube
sir.
live only. Na, you can go back. You can
Sir,
see.
how do we depict complement?
What? How did it affect?
How do we depict complement symbol? Like complement of x. How do we? What is the symbol for that? Like
Complement you can write a bar, a c. This all you can write. So this is nobody is going to ask you. But okay, if the how generally you write it, the complement as a complement, a to the power c, or you can write it a bar also. Many people represent like this, or many people represent a complement is simple. Whatever the element, that universal element that you have, except that a is the a complement.
Excuse me, sir.
Yeah.
Okay, sir.
Sir, I have a doubt regarding lecture 1.6, sir, which is membership and set relation. Can you explain that, sir?
We are explaining relations here. I mean, sir, please move on, sir. With relations.
Yeah, so
that is
I'll
where
come
doubt
upon
is.
that topic again after discussing this relation. Okay.
Yes, sir.
Okay.
Because in my notes, it is not in the order, sir. Like the membership one was said before, and you did not say that, so I thought you forgot.
Okay. Okay. So yeah.
Yes.
So let's
Sir, are we
discuss.
going to take week 3 and 4 also today?
No, week
No.
3 and 4 I'm not like going to discuss, because we already passed half of the time in week 1 and we didn't.
Yeah, so
even
are you
discuss.
going to take any another session for week 3 and
Yeah,
week 4?
yeah, it will be there. It will be scheduled. So okay. So let's
Sir,
discuss
can you
this. So
please
I
repeat
told.
from Cartesian product for once?
Okay,
Sir.
okay.
Again,
So
sir, please.
I told you the Cartesian product of two non-empty set, I told x and y, is defined as the set of all possible ordered pair xy such that x belongs to capital this set x, y belongs to this set y. Okay. And what is that Cartesian product? Is x cross y. If I took an example, x as a, b, and y as 1, 2, 3, you will be having how many numbers of set in that relation? 2 into 3, 6 elements will be there. And how will you write it? Like, how will you write? A1, A2, A3, B1, B2, B3. Okay. And simple. So this was done. Now this relation, a relation between two sets x and y, is a collection of all the ordered pair containing one element from each set. Okay. So in the set, what did we read? The order was not important, but here the order is important. Okay. So the relation between two sets x and y is a collection of ordered pair containing one element from each set. In other words, you can say that a relation R is a subset of all the Cartesian product of x and y, right? So any relation, okay, so that statement, okay, forget it. The first statement, whatever I told you, a relation between two set x and y is a collection of all the ordered pair between containing one element from each set, right? If you have x and y, I told you x is a and b. What are you doing here? You are doing what? You are taking one element from each element, okay, and mapping it to the other element, correct?
Yes, sir.
Yes, sir. Yes, sir.
Excuse me, sir.
Sir, to write a relation, we need to define a relation, right? First.
You have to define a relation. That is fine. I was just telling you in the form of the basic one, the binary relation, that if you have two sets and if you are doing just the product, okay. So for the
Sir,
relation,
can
you
you
have
please-
to should be having some relation that should be defined. Then only you can write it.
Sir, can you please repeat the brackets one just once? The
Okay,
meaning
so
of brackets.
Bro,
okay,
watch
so
this
there
on
basically.
YouTube. Don't repeat same thing again and again.
Okay,
Sir,
okay,
we
okay.
are
Okay,
running
I'll,
so
I'll,
much
okay,
time.
okay. Wait. I'll do that. Okay, the time.
Go
Okay.
through the videos. I mean, let's concentrate on what he's teaching us.
Yes.
There's no point asking him to repeat again and again.
Yeah.
You're right.
Okay.
Yes, sir. I think you should continue.
Okay, I'll do.
Just be with the flow.
Okay, please mute yourself, everyone. I'll just that won't take like more than 30 seconds. So there is 3 bracket. The one is the open bracket. If you have something like a comma b, That means the number A from, like, for example, 1 to 2. So all the numbers from 1 to 2. So all the rational number from 1 to 2, excluding 1, 2. So 1, 2 is not will be there. If we'll close this bracket, that means this 1, 2 will also be included. That means this A and B will also be there. And if this is a curly bracket, that means only A and B is there. Only A and B. That's it. So this is the 3 bracket that we have discussed. Okay, let's move to the other part. Yeah. So relation, I discussed the basic thing about the relation. Okay. Let's, for example, I have this A as, I told you this AB and 1, 2, 3. Can somebody tell me whether B3 is a relation or not?
Yes, it is a relation.
Yes, sir. It is
Yes.
a relation.
Relation.
Okay. So, and 1 is both
Yes, sir.
same. 1, this is
No,
same or
sir.
not?
Because the position is
No,
changed.
sir.
They are different.
Order
Correct.
is important.
It's not same.
Yeah,
It is different,
A1,
sir.
this is different because A is coming from the first set and 1 is coming from the second
Yeah,
set.
second
But
set.
here 1 is coming from the first set itself. So that's why both are not same. Not
Yes,
same.
sir.
But in the set we read that order was not mattering. Here order matters. Okay.
Excuse me,
So
sir.
now I'll
Only the
discuss about,
coordinate of the order matters, right?
correct.
But
Excuse
we
me,
can
sir.
write the elements in any order.
Okay, elements. Which elements you are saying? This
So
we
like we
can't
can
write.
write B3 above
Okay, yeah,
before
that
of
you can
AY.
write. Yeah, B3. Yeah, you can write it B3 first and then B2. You can write it like that. Doesn't make any sense.
Element
Okay.
doesn't, yeah.
Sir, basically we write the relations inside a
Doubt
set, right?
open session is there, sir. Please. Time is already gone.
Yeah. So now
It's
we'll
a
discuss
revision
the,
class.
yeah. So now we'll discuss the relation and the properties that we have discussed. The properties. So generally, and this is very, very important. I told you. So you can expect some problem directly from the properties itself. Okay, you can be given some relation and then you need to pick out which of them is the correct, whether it's a reflexive one, whether it's a symmetric, or whether it's a transitive one. Okay, so this portion, please hear it carefully, whatever I'm telling you. The first property is the reflexive. And please mute everyone. Please don't pick out anything. So reflexive relation. Okay. So the reflexive relation is what? Let R be a binary relation on a subset on a set S. Then R is said to be a reflexive. See, R is said to be a reflexive if and only if for all X belongs to S. X comma X is available there in R. See, reflex, if we are getting any confusion regarding the reflexive relation, so what you can do is, whatever the element is been given in your S, okay, just write it like A, like for example, S is a sum set that A, B, C or something is there, A, B, C is there. Okay, let's for example, S equals to some 1, 2, 3, 4 is there. Okay, and if you're writing, so reflexive is what? All the elements should be there, like 1, 1 should, if this is a set in your relation set, that 1, 1, 2, 2, 3, 3, 4, 4, all the 4 should be there. That is why I told you it is a reflexive if and only if for all X belongs to S. I told you for all, this is the word that is very important. For all X belongs to S, XX should be available, should be there in that relation R. Okay. So if we have some 1, 2, 3, 4, and if I'm telling you R is a relation, and that R is a relation is what?
Sir,
1,
what you have
1,
written,
2,
if
2.
R, sir?
Here,
Yeah,
if,
yes, sir.
Yes, sir.
if and only if for all X belongs to S, S is a set, XS is available in that relation.
Yes,
Sir,
sir, got it.
your voice is buffering, sir. Can you please repeat?
Yeah. So I was telling you, let R be a relation on a set S. Then R is said to be reflexive if and only if for all Sx, this or for all x belongs to S, Xx should be there in the relation R. Okay, let's for example, with the example maybe you'll understand. If R is a relation where 1, 1, 2, 2, 3, 3 is present and then 3, 4 is present. Is it a relation? Is it a reflexive relation?
No.
No, this is not a reflexive relation because 4,
Yes,
4
sir.
is
4 is absolute.
4, 4 is not available. And I told you it should for all the values of x. Whatever is there in S should be there in that relation. That okay. So let's for example, I'm telling you, so whenever you are making, let's if somebody is getting confused, one just put it all the elements like this 1, 2, 3, 4 and see this relation. This relation is what? This is relation from what? 1 to 1 itself. So this is a 1 to 1. This is 2 to 2. This is 2 to 2. This is 3 to 3. This is 3 to 3. Can you see any 4 to 4? No, right? So one vertices, like it's just the example. If somebody is getting confused, it's just the example I'm telling you. Whenever you are writing in this form, every vertices should be having a node itself. Okay, for 1, 1 it's there. The relation is for 1, 1 is there. For 2, 2 it's there. 3, 3 is there. 4, 4 is not there, right? 3, 4 is there. This is 3, 4. So 4, 4 is not available. So that means this is not reflexive. Okay. So I told you this word is very important. This all word. So this is for each and every value of x belongs to S. There should be xx in that relation. Okay, is this clear to everyone? This
Sir,
reflexive
if there
relation?
are 1 1, if there are 1 1, 2 2, 3 3, 4 4 and plus 3 comma 4, is it reflexive?
Yeah. So if you have a
One
relation
excess,
like
one
okay, so
excess,
let's
3
for
comma 4.
example this 4 4. Okay, this is the example.
Sir, I am
okay, you have
confused between identity relation and this reflexive
wait.
relation, sir.
Please wait. I will tell you. Please wait. The reflexive is I told you this is a relation 1 1 2 2 3 3 4 4 and 3 4. Okay, so this is a reflexive relation because what are the conditions that should be getting fulfilled? That if for all x, xx should be there. So for all x, x is 1 1 2 2 3 3 4 4 is there. We are not bothering about this 3 4. Okay, if we have 1 1 2 2 3 3 4 4, that's it. It's a reflexive. So we don't have to see this 3 4 and 4 3 any other relation. Okay, we just have to see whether this the condition for the reflexive is getting satisfied or not. If this is satisfied, that means it's a reflexive. Okay.
Oh, sure, sir.
Okay, sir.
And sir, one doubt, sir.
Yeah.
We can define a reflexive relation only on that set to itself, right? I mean, suppose there are two sets like A and B, we cannot define a reflexive relation between set A and B. We can define reflexive relation only to A to A, right?
Yeah.
Okay, sir. Thank you.
Okay. So this reflexive, the first properties I discussed. This is clear to everyone.
Yes, sir. Clear.
Yes, sir.
Okay.
Yeah.
The second one is the symmetric.
Sir, what is the difference between anti-symmetric and symmetric relations?
I'll come upon this, brother.
Yeah, first one identity relation is also there, sir.
I'll come upon that also. So the second properties is what? The second is what? Symmetric. The second one is the symmetric relation. Okay, so I'll tell you the statement, just hear it carefully. Let R be a relation on a set S. Okay, then R is said to be a symmetric if and only if for every x and y belongs to, for every x and y belongs to R, y and x should be there in the R. Then only this is a symmetric relation. Okay, so wherever you are seeing xy, that yx should be present. Yes. Okay.
Yes, sir.
Yes, sir.
Sir, by this definition, we
every
can say
X and
reflexive
Y,
relation also symmetric, right?
What?
By this
Yeah,
definition, we can
reflex.
say reflexive relation is also symmetric, right?
Yeah, you can, no, see, no, that you can't say, no. I told you for C, if all the X and Y are
Sir,
equal, then you can
one
say.
is there. So, see, for example, one is there. Then one is again. I mean, XY is there. Then
If
YX
this
is also there.
condition is fulfilled, every set, is relation is the
See.
symmetric relation. Okay.
See, if only 1, 1, 2, 2, 3, 3, 4, 4 is there, then that is a reflexive and symmetric both.
Yeah,
but
that's what.
but if you have 1, 1, 2, 2, 3, 3, 4, 4,
2, 4.
and 3, 4, then this is not a symmetric, right? Why this is not a symmetric? Because for all these conditions,
4-3 is not there.
4-3 is not present. Okay.
Yeah.
Correct. So this is a reflexive but not symmetric. So I'll tell
Yeah,
you the
yeah.
reference
Okay.
again. In the reflexive one, that XX, YY, all the element that XX should be present. For each and every element, for all the element,
Got it,
XX should be present. But for the reflexive, if XY is XY is present, then YX must be present. If XY is present and YX is not present, that means it's not a symmetric relation. Even for
Got it, sir.
one case, even for a one case. Okay.
Got it, sir. Got it, sir.
Got it. Then
Got
this
it, sir.
third
Got it,
one
sir.
is,
So what if this 3, 4 is not present in this relation?
Transitive relation.
yeah, what if
Sir,
this
all
3,
the
4 was
reflexive
not
are symmetric.
If
It
3,
is
4 was
symmetric or
not
not?
present, if you'll mute yourself, then only I'll be able to say anything. Yeah, if 3, 4 is not present, 4, 3 is not present, then if this is a relation only, then this is reflexive also, and this is symmetric also. Because symmetric is what? XY, if XY is present, YX should be present. If XY is present, let's for example, this is X, this is Y. That means what? X is also 1, and then YX is YX present, is 1, 1 present? Yeah, 1, 1 is present. Similarly for 2, 2, 2, 2 is present. For 3, 3, 3, 3 is present. Similarly for 4, 4, 4, 4 is present. So this is a symmetric. If only this is there, and this is reflexive also, because reflexive, for reflexive, the only condition is for each and every element that 1, 1, 2, 2, 3, 3 all should be present. Okay.
Then, sir, if it is symmetric, then it will definitely reflexive.
If only.
Sir, are we going to discuss weak
That is
No,
wrong.
that
because
is
it's
also
already
not correct.
9:30?
Yeah, that is also not correct. If let's for
That is wrong
example, for
statement.
this case also, if 3, 4 and 4, 3 is present, only these two cases are present. Whether this is symmetric or not.
That is symmetric, but
That
not
is
reflexive.
symmetric, but not reflexive.
This is symmetric because whatever X and if
Not
for X
reflexive.
and Y and X should be present. That's it. That is the thing. And the third one is, okay, I'll just increase my pace now. The transitive relation. And for this transitive relation, what is the definition? If let R be a relation on some set S, okay, then R is said to be a transitive if and only if in every pair of the element XY and YZ is some relation R, then XZ should also be present. If XY is present, YZ is present. So see, whenever you have to see the transitive relation, first check for each and every element, check if XY is present, just search for the Y, for the first element of all the set. Just see that in which of the following the first element is Y. Okay, if XY is present and YZ is present, then XZ. Then see for XZ. If XZ is not there, then you can directly say it's not a transitive set, transitive relation. Okay.
Okay. Sir, one second, sir.
Okay, I'll give you example and that will clarify your everything. 1, 2, 3, 4 is there. I have a relation only 1, 2, 2, 3, and 1, 3. Okay.
Not transitive.
Is it transitive or not?
Not yeah, it's a transitive.
Yes, transitive.
It's
Yes,
a transitive. Why?
It's transitive.
So if X,
Yeah,
Y is
1,
present.
then 2, 3, then 1, 3, sir. Next
Okay.
one.
Okay.
1,
So
2, 3, that the 2 is common. So the third pair 1, 3 would be possible for coming.
Correct. So it's see 1, 2 is present. What I told you, if 1, 2 is present, so see for all the sets where 2 is the first term. So 2 is here. So 2, 3 is also present. Then search for 1, 3. If 1, 3 is present, that means
It's
what?
transitive.
It's a transitive.
transitive. It is transitive.
See, there 2, 3 was present. I was searching for some element where the first term should be 3, but there is nothing, right? Can you see any set, any element which has the first element is 3? No, right?
No, sir.
You can't see. So that's why I left it. Then I see for 1, 3. Again, I am searching for that element where the first element is 3. There also I can't find it. Okay, so I just found it for 1, 2. I just found 2 was there for this element, the first element of this relation. Okay, 2 I just found it, and 2, 3 was there. So I searched for 1, 3, and if I am able to find 1, 3, that means for this at least for 1, 2, 2, 3, 1, 3 is present. Then I will see for the other cases also. For this cases 2, 3, I didn't find any element which starts with 3. I didn't find any element, right? Again 1, 3 was there. I didn't find any element which starts with 3. That means for other cases, xy is only present. We are not bothering about xy.
What will happen, sir, if in the same set there is one more element like 1, 4?
Sir, are we not going to discuss week 2 today, sir?
We'll discuss it. We'll discuss it.
Sir, I have a question.
Please be
Okay.
patient.
So
Ma.
see, 1, 2
Let
is
him allow
present.
to do.
1, 2 is present. 2, 3 is present. Let's, for example, this 3, 4 is also present. Then this is not transitive because 2, 3 is present. 2, 3 is present. 3, 4 is present. 2, 4 is not present. As 2, 4 is not there, this is not transitive. Correct?
Sir, but the condition is something
Sir, I
like,
don't get it, sir.
AB is there, AB is there, and then we can look. We need to look for if only BA is there. Then only we have to look for AC, right? I mean the third condition.
Correct, correct. So here.
So it is transitive, right?
See, 1, 2,
no,
2, 3, 1, 3, and 3, 4.
Yeah.
2, 3 is there. 3, 4 is there. 2, 4 should be there, right?
Yeah, 2, 4 should
is
be
not,
there. Yeah.
If 2, 4 is not there, that means it's not a transitive, correct?
It's not a transitive. Yeah.
Yeah, sir, I have a question.
Go ahead.
Yeah, in the R is equal to 1, 2 or 2, 3, 1, 3. Is it also a asymmetric?
Asymmetric, have you been taught asymmetric?
Yeah.
I guess asymmetric is not been taught.
It's not there in syllabus, I think, sir. There was only one question in graded assignment, and I was like, I checked with somebody and they said it's not there in syllabus, so I just left it. That's it. That question came in by mistake or something. That's it. It's not there.
Okay. See, I'll tell you the difference. See, so anti-symmetric also, if you want to understand, you can just understand. So this is the difference between the symmetric, anti-symmetric, and the asymmetric. Okay, symmetric is simple. I told you for all x and y belongs to x, xy is present, then yx should be present. Anti-symmetric, that is there in the lecture. Okay, what's there? A relation is anti-symmetric if and all there can be two conditions. What is that? Xy belongs to x such that if xy is present in that relation and yx is also present in that relation, that means that then x should be equals to y. Then only this can be anti-symmetric. Okay, and what's the difference with the asymmetric? In the asymmetric, see, in the asymmetric, if let's for example xy is present, okay, if xy is there in that relation, that means and such that, see, if you have a relation is asymmetric for if for all xy belongs to x. So there can be any set, let's for example a 1, 2, 3, 4 itself. Okay, and then you have xy belongs to R. So you have a relation R where xy is belonging to xy is there in the condition. So x R y. So x is a relation with some y, and then if see where it went. So in the symmetric, what was the case? If xy is present, yx should be present, right? That is a symmetric, correct? But for asymmetric, it's totally opposite. Asymmetric is totally opposite. If xy is present, yx should not be present. For all the cases, I told you, for all the cases, if 1, 2 is there, 2, 1 should not be there. Okay?
Got it, sir.
For all the cases, then this is asymmetric. Okay, and for the anti-symmetric, if for all x and y, if xy is present and yx is present, And it can happen only in that condition when xy are same. Okay, and if xy are not same, then yx should not be present.
Right, sir.
It's a
So
bit
then in that
confusing.
case,
Yeah.
that's also reflexive, right?
What?
For anti-symmetric, if xy is there and yx is also there, given that x and y are same, that is also reflexive.
Your voice, I can't, like, there's some noise while you speak. There's some noise.
Sir, can you explain it by giving examples?
Okay.
Asymmetric and anti-symmetric are different.
What?
Yes, sir. Anti-symmetric or asymmetric examples.
See,
They are different.
asymmetric is totally opposite of the symmetric, whatever you have read. Okay.
So
Can you
we'll
please
use
mute?
two derivatives.
Everyone, please mute yourself.
Someone is
Sri
disturbing the
Gupta,
class.
please mute yourself.
Arjun Kumar is disturbing.
Khushi Gupta.
Yeah, please mute yourself, everyone. Okay.
Sir, can you please write the correct one of transitive relation?
Okay, so transitive.
You have
okay, so
written the wrong one, sir.
what?
You have written the wrong one. What will be wrong? But write the correct one. What will be the correct one?
For the transitive?
Yes, sir. Yes.
See, for the transitive, I'm giving you some examples, and that will clarify everything. See, I have a set S.
Sir,
Yeah.
in the question above, can you please scroll up a bit?
Okay.
Here. 1, 2, 2, 3, and 1, 3. This is a transitive relation. But
Yeah,
if
this is a transitive.
if we include 3, 4 and 2, 4, there will be one transitive relation and another. If we consider 2 as x, 3 as y, and 4 as z, then will it be transitive relation
Sir is
over
explaining this with an example again.
See, if you have just this 4 element, this 1, 2, 2, 3, 1, 3, and 3, 4. This is not a transitive because 2, 3 is there, 3, 4 is there, 2, 4 is not available, right?
Then we will not consider the first relation which is formed.
No. See, I gave you, see, there is one relation R1, and that relation is what? 1, 2, 2, 3, 1, 3. Okay. So this is what? This is a transitive one. But if you are relation, some different relation, this is the first question you have been asked. Okay, this is R1 is a relation on S, and this is 1, 2, 2, 3, 1, 3. Is it a transitive? Yes. Yes, this is a transitive. But if you have a second relation, where second relation is what? 1, 2, 2, 3, 1, 3. 1, 2, 2, 3, 1, 3, and 3, 4. If this, and then you have been asked whether R2 is a transitive, then it's no. Why? Because 2, 3 is present. Even for, see, 1, 4 is not there, 2, 4 is also not there.
2, 4.
Correct? If you have been given 2, 4 is not there, 1, 4 is also not there because 1, 3 is there, 3, 4 is there, 1, 4 is where? Where is 1, 4? 1, 4 is not available, right?
So what if that last thing is like 4, 3?
What 4, 3?
I mean, instead of 3, 4, what if it is with 4, 3, sir?
Okay, if I'm adding 4, 3. Okay, so this is what? This is see 1, 2. So please mute
Guys,
yourself.
mute, please.
Otherwise,
Sir, again, someone is disturbing.
yeah. So yeah. Okay, mute yourself. 1, 2 is available. 2, 3 is available. 1, 3 is available, right? Now
Yes, sir.
I'll see 2, 3 is there. So I'll check. I'll scan all the sets, all the elements. I'll just check all the elements and check whether any of the elements starting with 3 or not. I'll check. Okay, this is not starting. This is also not starting. That is fine.
It can be
Again,
3, 4 or 3, 3. Sorry, 3, 1. It can be anything.
Yeah,
But there should be 3. The first number.
First element should be 3. Okay, so I'm checking.
Okay,
so I can't find it. Again, I went to this number 1, 3. I can't find it. Again, went to 4, 3. I can't find it. Right? So any number, any element starting with 3. So that means what? This is a transitive.
Yeah. Okay, sir.
Okay, because for 1, 2, 2, 3 is there, 1, 3 is available, right? 4, 3 is like, I don't bother about 4, 3 because there is no any element that starts with what 3 or end with 4. If any number, if 1, 4 was there, then I would have checked. Okay, 1, 4 is there, 4, 3 is there. Then where 1, 3? If there was 1, 4, then I would have checked for all the elements that starts with 4, and I would have got this 1, 4, and then I would have checked for 1, 3. 1, 3 is present, then it's a transitive. Otherwise, it's not a transitive.
Got it, sir. Thank you.
So, sir, in the relation one, there is no no element starts with two. Another element in the relation one, sir.
In the relation one,
yeah, there is no other element which start with two.
This starts with 2, na?
Yeah,
1, 2,
there is,
and then I checked. Okay, 2 is there, so 2, 3 is available. So I told you, na, if xy is there, then and xy is there, and yz if you are able to find, then xz must be there. If xz is not there, this is not transitive. Okay.
Sir, if yz is not there, please.
Sir, it should be the whole like xy, yz, and xz. So, sir, there will be like in every.
If xy is there, and you should be searching for yz. If yz itself is not there, then directly you can say it's a transitive, right? Because you are not able to find yz.
Oh, okay, sir.
Okay, sir.
Got it? But if yz is there,
got it, sir. Got it.
Sir, can you give me example of transitive relation with lots of element, like 5, 6 element which where relation is transitive?
Okay, I'll just give you, this is the last example I'm giving for the transitive, and then we'll move to the function. Otherwise, we are not going to complete it.
Sir, we can move to the function, sir.
Mute.
Okay, so S is a S is a set 1, 2, 3, 4. I'm giving you one relation, that's R relation, as 2, 4, 1, 2, 1, 4, 4, 1, 1, 1, 2, 1. Okay. And if we are able to solve this, we'll be able to solve the questions in the exam. Okay, this is a set, and this is a relation. You need to say whether it's a transitive or not. So nobody is going to answer. I'll solve it. Okay. Otherwise, again, it will make a case. So 2, 4 is there. So I'll search for any element which starts with 4. So I'll go there. No. I'll go there. No. Okay. Yeah, this is there. So xy is there. Yz is there. That means I'll search for 2, 1. Xz. 2, 1 is there. Yeah, 2, 1 is there. So that is fine. Okay. Now we'll go with 1, 2. I'll search for any element that starts with 2. 1, 2. It's not starting with 2. It's not starting with 2. It's not starting. 2, 1 is there. So xy, then yz, then 1, 1 should be there. Yeah, 1, 1 is there. Right? And again, 1, 4, 4, 1. That means 1, 1 should be there. 1, 1 is there. 4, 1, 1, 1. 4, 1 should be there. 4, 1 is there. 1, 1, that 1, 1 is there. Again 1, 1, this 2, 1. Then if you'll see 1, 2, that means what? Right? So if you'll see for 2, 4, 4, 4, 1, then 2, 1 was present. Correct? Similarly for 1, 2, 2, 1, you saw, so 1, 1 is present. 1, 4, 4, 1, 1, 1 is present. 1, 1, 1, 1 is present. Correct? So what is this? This is a transitive or not?
Yes, sir.
Yes.
Yes, sir.
So we
Sir,
check
so
3 times.
basically,
Sir, we have to check every element.
Yeah.
Yeah.
Okay.
sir, so basically, sir, every element has to satisfy this condition.
Yeah. All elements should be satisfied. If xy is there, yz is there, xz should be there. That's it.
Sir.
So this is completing. So an equivalence relation is basically any relation that is satisfying all the three
Then, sir,
conditions.
if we get any one element absent, then it will be not transitive.
Sir, if any of the element is missing in this set, then it will not be transitive, na?
Yeah.
Can we move on, please?
Sir, have already cleared a lot. Now, please let us move ahead.
Yes, sir.
Sir.
So please solve that type of question which came in qualifier.
Those type of questions
Sir, please move on.
Yes, sir.
Sir has dropped off.
Sir is not
Sir is not
Sir
there.
got annoyed from it.
गाइस एक ही चीज पे क्यों अटक रहे हैं हम लोग?
हाँ वो
थोड़ा तो पढ़ के आते.
Yeah, it's not a first class. It's a
हाँ.
revision session.
Yeah, it's a revision.
भाई वीक 2 चाहिए था यार.
वीक 1 पे ही गोल गोल घूम रहे हैं लोग.
मतलब इन ये क्लास अभी तो फंक्शन ही कंप्लीट नहीं हुआ है अभी. हाँ भाई.
Waste our two.
ओपन सेशन में 40 जन आते हैं.
So, okay. So let's start with the function now. I just lost the connection somewhere, I guess.
Yes, sir, for returning.
Okay. So let's start now.
Function.
So you're able to see my screen, right?
No, sir.
No, sir.
Yes.
Not now.
Yes,
Yes,
sir.
sir.
Okay.
No, fine, sir.
So function, okay. So the function is basically a relation in which each element in set X is mapped or paired with exactly one element in the set Y. Okay. So I'll just give you one example. In a function, what did I told you? A function is a relation in which every element in set A is mapped with exactly one element in set Y. Okay, there should not be any confusion in this. In a function, there should not be two pairs with the same first element. Okay.
Yes, sir.
Okay, sir.
Let's, for example, you have a relation 1, 2, sorry, a function 1, 2, 3, 4, and you have A, B, C, D, and you have X, Y, where 1, 2, 3, 4, and you have A, B, C, D. Okay, and this X is what? X is a relation with, say, this one, and 2 is having relation with some C, 3 is with A, and then 4 is also with A. So is it a function or not?
No.
No. Yeah.
Yes.
Yes, it is.
It's a function, sir. It's a function.
Yeah, this is a function, right?
Yes.
See, from
Yes.
It's a
one
clear
to
function, sir, and one-to-one function.
correct. It's
Anyone.
not one to one, but
No,
like,
not
yeah,
one to
it's a
one.
function.
It's neither one to one nor on to.
Okay,
not
so
one to
2 and 4 goes
okay,
to
so
6.
this is
So
basically a
on to means
function.
all y must be used with all elements of y. And one is only one. It is many one.
Hey, first get the difference between whether it's a function or not. So this is a
Many one.
function.
It is a
Okay, why
function.
did it's a simply a relation? Each element of X is mapped with exactly one element of Y. Correct?
Yes.
Yes,
Yes,
sir.
sir.
That is right, sir.
We have been given something like this: A starts with A, B is there, and C here, and then this is not a function.
Yes, sir. Not.
Yes, sir. Not a function. 3 gives 2 output and
Okay.
4 doesn't have any output.
Correct. That doesn't, yeah. So basically 3 is mapping to 2 values. Okay. So now, and what's the types of function?
So here one and on to one and on to.
So injective, surjective, bijective, sir.
Yeah.
So the
So you
function
have,
means all elements of y must be used, or each element of y must have only one element from x, or each element of x must have only one element from y. Just clarify this.
okay, see, if you have a function something like this is a function. Is this a function?
1x has 2y, so no.
But this can be a function, right? For one value of x, you are getting one value of y. Hey, I
Yes.
guess the net is not
Yes.
as
So 1x
okay.
must have 1 y.
Yeah. So this is not a function, but this is a function, right?
Yes, sir.
Yes, sir, got it.
Yeah, correct. Okay, so let's the type of
So
function is
1
what
to
the
1
first one
means
is.
1x must have 1 y, right? So could you also fill 1 to
Yeah,
1
so
and
I'm discussing that. This is injective. If each element in set X, if each element in set X is mapped to a distinct element in set Y, then the function is the injective or the 1 to 1. Okay. The second one is
Surjective, sir. Surjective.
Surjective, sir.
it is not.
Again, connection lost.
No.
Very slow.
This is A103 who making
Yes,
noise
sir,
all the time.
discuss adjective, isn't it? Anyone can tell me. Sir have discussed subjective.
General question before until sir comes. Like, did you guys get mock test quizzes for mathematics?
Yes.
Like you got the
Yes.
stats?
Yes. It is available. Yeah.
When did you guys get it?
I think yesterday.
Yesterday. Let me check once.
I don't
yes.
get math.
Can you hear me now? Are you guys able to hear me?
Yes, sir.
Yes, sir.
Yes, sir. We can hear you.
So I was just talking about the injective function. Injective is like if each element in set is mapped to the distinct element in set Y. Okay, and surjective is what? If the range is equals to the codomain. Hey, are you able to hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And the third one, if both the condition is been satisfied, then we call that as a bijective function.
So kindly repeat
Okay.
surjective.
Yeah, see,
Right.
the injective is what if each element in set X is mapped to a distinct element in set Y. Then the function is injective or 1 to 1.
Sir, please explain again.
See, there's a difference. The injective
And surjective.
so each element
Have 1 image.
in set X is mapped to a distinct element in set Y. Okay, and here is what range is equals to codomain. So range is what the exact output that you are getting for any function, and codomain is the expected output that we were supposed to getting. Okay, let's for example, if any function is there from R to R. Okay, so the codomain is what the value that you are putting inside the function is the real number, and the output also you are thought like the codomain should also be a real number. And if the range is also satisfying that the range of the function is also the real number, then that is a onto function. Okay.
Yes, sir.
Sir, can I ask one doubt, sir?
Yeah.
What if a relation is like defined from integer to rationals?
What's the
And,
difference between integer and decimal number?
Integer to rationals, Z to Q.
What
Z
Z
to
to
Q, and the function is like maybe x equal to y or something. And
Effects.
there will be a lot of elements which are left in the codomain. So in that case, can we call it as a
No, you
injective
can't
function?
call. No, you can't call it injective. To it's like totally different.
Yeah.
Surjective is depend on range and
Subjective we cannot call, but injectivity. I mean, there can be leftover elements in codomain, right?
Yeah, so that doesn't make any difference, right?
Yeah. Okay. Thank
you. So for the injective, each element in X should be mapping to a different element in Y. That is the sufficient condition. Okay.
sir. Yeah.
For the surjective, that range should be equal to the codomain. Okay. Yeah. So there's not like if some values are left, that doesn't matter. Like for the injective.
Okay. Okay.
You can, if both are satisfied, then you can call that as a bijective function.
Bijective. Yeah.
Okay. So this. So I told you this. So this was for the week 1 content, and the important portion is that you can be asked the questions related to, like, you have been given the relation, then you have been asked whether it's a transitive or not, or whether it's a equivalent relation or not. Okay, and then for the function also you have been asked whether it's a bijective function or not, or surjective function or not. Okay, or injective or not. Okay, so this type of question is very common, and you can be get prepared for those type of questions. So you should be expecting those type of questions in the exam. Okay.
Sir, when we will do week 2, like it was today.
Yeah, so let's start week 2 now. So week 1, I told you whatever the important portion is there, and please be prepared for those all portion, whatever I told you. Let's start week 2 now. Okay, so week 2 won't take much time because there's nothing that important to discuss. Week 2 is pretty simple. You'll be able to solve the questions. So I'll just start discussing the week 2 content now. Okay, so week 1, I told you the important portion, right? Relation, function, and the set. Please revise it again and again. Solve as much as problem you can. Try to solve the graded one, practice, and the mock. Okay, all the 3. Okay, try to solve this. So let's start the week 2. Week 2. Okay, so in week 2, so what is there in the Cartesian plane? So what is the Cartesian? You already know what is Cartesian coordinate system. We have like basically how many coordinate we have? We have X and Y. How many quadrants are there? 4 quadrants. 1, 2, 3, 4. If we have 3 dimension, how many coordinate would be there?
3, sir.
3.
How many quadrant would be there?
Sir, can I leave, sir, if I don't have any doubt?
Yeah, you can do.
Thank you.
Okay. For 3 dimension, how many quadrants should be there? 8, right?
Yeah.
Okay. Yeah. You already know X is also known as abscissa, and this is ordinate, right? Correct. So this is pretty simple. It's pretty simple. So now next is that distance between 2 points. Distance between 2 points. You already know the formula, right? If you have x1, y1, x2, y2. What is the formula? This is simple, right?
y1 equals to
minus x1 ka whole square plus y2 minus y1 ka whole square. Under root. This is the length. If this is A and this is B, the AB is this one.
Yes.
Okay.
Yes.
So it's pretty simple. Now you have what the important. This is important section formula. So you can be asked from this portion section formula. Okay, section formula. So if internally or externally both. So you can have like A, B, and then it's like something.
Sir, we don't have external section in syllabus. We can discuss only about internal.
Okay. So internally, if this is discussed, like you have to use the section formula. If you have 2 data points x1, y1, and this is x2, y2. So you have to find out the You have to find out the coordinate where it has been divided by m divided in the ratio of m is to n. So you can write the coordinate, right? X is what?
Yeah.
M.
mx2
So you can,
plus mx1 by m plus n.
yeah, mx1 plus m plus n. Similarly, you can write for the y also, my2 plus ny1 upon m plus n.
Yes.
Correct?
Yeah.
Yes,
That's
sir.
right.
Yes,
So
sir.
this was pretty simple, right?
Yes, sir.
Now what's
Yes,
there?
sir.
Like you have to calculate area
Slope.
of a triangle.
Okay. Yeah.
Correct? You have the formula for that.
Yeah.
Be thorough with this. Like you can be asked, three coordinate can be there and then can be asked regarding the calculate the area of the triangle. You are aware of the area of the triangle, right? X1, then y2 minus
Y2 minus Y3
X2, Y3
plus
minus
X2
plus X3, Y1 minus Y2.
right? And then x3, y1 minus y2.
Minus y2.
Y2.
Yeah.
Okay. And see, if you are getting the area as a 0, that means what?
That's a straight line.
Straight line.
Linear
All the
points.
points are
Number
collinear,
is-
right?
Yeah, yeah.
Collinear.
That's a straight line.
Okay, that like all the points are lying on a single straight line. That's
That's
why
right.
the area is
Zip.
0. Okay.
Yes, sir.
Yes.
Now after the area of you will taught about the slope of a straight line,
That's right.
right? What is the
Yeah.
slope of a straight line? You already know, right?
M
M is equals to what?
Rise by run.
y1 minus
Delta y upon delta
x1
x.
minus y2 minus
y2 minus
minus
y1
y1
upon x2
Minus
minus
upon
x1.
x2 minus
Minus
x1.
And this is
x1.
what? This is also
Tan
tan
theta.
theta also.
Tan theta.
Okay, tan theta is what? This is the theta.
Yeah.
Yes.
Okay, so the
With
slope is
respect
what?
to
M is
positive
equals to
x-axis.
tan theta. Correct?
Yes, sir. With respect to positive x-axis.
Yeah, with respect to the positive x-axis.
So
Okay.
can I scroll
Now,
up?
okay, if you have two parallel lines,
Same slope, sir.
yeah, so both will be having m1
Same
will be
Same
equals
slope.
to what? M2.
Same slope.
Correct?
M1 equals
Yeah.
to
And if you have two perpendicular lines,
M1, M2 is equal to minus
equal to minus 1.
m1
M1 into
product of
M2
m2 equals to
minus
minus
1.
1.
Minus 1.
Correct? So if you have been
Yeah, yeah.
given a straight line with the slope some m1 and you have been asked, like you have been told that both the lines are perpendicular, and then you have been asked to calculate the calculate the slope of the other one, you can calculate, right?
Yeah,
Yes.
yes, sir.
Yes,
We
sir.
can.
Yes, sir.
Okay. And now we have been discussed about the equation of straight line.
Yeah.
Okay. So there are like 3-4 methods by which we generally write the equation of a straight line.
Straight line.
The first is the what?
Y is equal to mx plus c.
Mx plus c.
Y equals to mx plus c. This generally is what?
I mean, slope point form. Oh, slope intercept form. Yeah.
Slope intercept form. Right?
Yeah.
The second one is what? The point.
Slope point form.
2 point.
How will you write this? Y minus y1
Y1
equals
Is
by
equal to
m into
M
x minus
X
x1.
minus X minus X.
correct. The third is what? 2 point.
Slope.
Yeah, yeah.
Y1 is Y1.
Y minus y1. You just have to replace m. Now, how will you
Y2
replace?
minus y1 by
Minus
x.
Y1 by M2. X2 minus X.
X
X
minus
minus x.
Yeah, right. And then you have what? Angle
Between
between
two lines.
two
Nine
lines.
M1
So,
minus
yeah,
Alpha
M2
minus
by
beta,
1 plus
sir.
M1
M2
M2.
minus m1 by 1.
yeah. So if you have two lines with slope m2 and m1, what is the formula for that? Tan theta equals to
Tan theta.
M2 minus
M2 minus
m1 by
M1 by
1
1
plus
plus M1
m1
M2.
m2.
correct. The formula.
Sir, how do we consider M2 and M1, sir, here? What is M1 and what is M2? Like, which formula, which equation will be M1 and
See,
These are two slope.
these are the two slope of a like see. You can take any value as m1, any value as m2. Okay.
Okay. So if we take like M1 as the largest value, larger value, large slope, then that will be negative, right?
So it will be if negative, so you'll get the according to that only you'll get the if you'll get the negative value. So means you are getting that some see if you have a straight line like this.
Sir, firstly, we have to find the value of M1 and M2, right, sir?
See, if this is something, this you can take as what? M2. This you can take as M1.
Yeah, that's right, sir.
Correct.
But
This
we
is
are
what
checking
we
the
got.
angle between two lines, right?
Yeah, we are checking the angle between. So this can be your theta, right? This is the theta
Yeah,
between
then
M2
that
and
can be
M1.
theta.
Okay, so I told you 2, 3 like equation of line. I already told you there are
Yeah,
some
yeah.
other. Yeah, so some general form is simple, right? Ax plus
X
by
X
plus
plus
c
by
equals
plus
to
C.
0.
That's right.
Slope form you already know. Slope
Yeah,
form
yeah.
intercept. See if you have like y equals to mx plus
c.
C is what? C is the intercept of what? Whether it's
C
a
is
y
the
intercept or
intercept.
x. It's a
Y
y
intercept.
intercept, right? So it's a y-intercept. So condition of parallel you already know. If you have two straight line been given, if okay, so we have been given ax1 plus by1 plus c1 equals to 0 and ax2 plus by2 plus c2 equals to 0. And you have been told that both the straight line are parallel to each other. What are the condition that will satisfy?
They must have the same slopes.
Same slope, right? So y1 equals to what? Minus ax1 upon b minus c1. Similarly, y2 equals to minus a upon c. A1 should be a1, b1, c1, c2. So this is a1, b1, a2, b2, x2 minus c2. And both should be equal, right?
Yeah, yeah.
A1 upon b1 should be equals to a2 upon b2.
B2. Then it will be parallel.
This is parallel. And similarly, for the perpendicular also you can say, right? This
Yeah, yeah.
a
We can check the slopes,
multiplication, a2 by
must be equal
b2
to -1.
minus 1. Correct. What else is there? Yeah. And the
So
distance
between two parallel lines.
Now the remaining distance between two parallel lines. That is simple, right? C2 minus
C1
upon
by
a square plus b square. Similarly, you can calculate the distance of a point from a straight line also. How will you calculate this distance?
ax1 plus by1 plus
Yeah,
plus
so if
C.
this is
Yeah.
x1, y1, you can calculate like this. What? ax1 plus
Plus
by1 plus c
C
upon under
A
a
square
square
plus B square.
plus B square.
correct. If this is ax plus by plus c. Similarly, what else is there? The ss. This is what?
Sum of squares of errors, sir.
The squared error.
Yeah, that is the procedure to be followed, right?
Yeah, and this is important.
Yeah,
So
one question
you
will
can
come for
expect.
sure, right? I have seen in almost all the previous year question papers. One
So you
question
can
is there
expect
from SSC.
yeah, you can expect the question from this sum of the squared error, and this is simply the deviation that you have to calculate. Okay,
Yeah,
the
that's
basic formula yi minus mxi minus c ka whole square from I equals to 1 to n. Okay, so see if we are
Sir,
not
give an
getting.
example from SSC.
Okay, let's for example, you have been given a data point. So you have been given the data points xy. Okay, and the data points are 1, 2, 2, 3, 4, 5. Okay, this is the data point has been given, but the model, the earlier
Sir,
model was
in
given
all
as
the
y equals
questions
to x.
they will give one equation and they will give
So, yeah, this
what is x
equation has
and what
been
is
given.
y
Okay.
also, right?
Oh, so this is like y equals to x is the equation. Okay, if we have been asked to calculate the SSC, and this is the data point base given. So according to this equation, y equals it should be 2, it should be 3, and it should be 5. Now calculate the difference between this y minus y cap, and then square it. So what is that 2 minus 2 ka whole square? Is 3 minus 3 ka whole square. So for this case, it is 0. Sorry. Y equals to x is there. Right? It should be 1, 2, 4. Should be 1 to 4 now. Here it is y equals to x. So see, I'll just let you know again. So if you have data points 1, 2, 2, 3, 3, 4. This is given. This is x. This is y. And your model is what? Y equals to x. So what you'll be getting here? 1, 2, 3. Right? What is the deviation that you are getting? The deviation should be the given data, whatever the given data is, y minus y cap. Okay. So y minus y cap ka whole square. So this is what? 2 minus 1 ka whole square plus 3 minus 2 ka whole square plus 4 minus 3 ka whole square. Okay. Got it?
Yes.
Yeah, so you just have to calculate the deviation and square it for each and every term.
One question for sure from SSC.
So the chapter 2 is pretty simple. You can expect some simple question like calculate the.
So here at last in the SSC, then we will take out the summation. Then what you will do?
That is your answer, right?
Okay.
The deviation you have to calculate, right? The sum of a squared error. So whatever the error you are
here
getting,
it is the answer is 3.
Yeah, for this case it is 3. You have been just asked about the sum of a squared error, the error that you are getting. Okay, y equals to x was the exact straight line, but the value you are getting different. So what's the error that you are getting? What's the deviation that you have got from the straight line given? Okay, so this is the deviation that you have got.
But if we have two lines to compare, then the one with the least error
will have the best fit.
Correct.
Correct.
Yeah, correct. If you have to like for example, one model you have prepared, one model I have prepared, and then I need to see the square error. So what's the deviation for your model and what's the deviation for my model, and then we'll see whichever have the least error will be a good model to like this generally used in the ML and all machine learning. Generally, we calculate the error and see whichever the model is having the least error is a good model to use. Okay, and this is how it works. And
So
SSC generally use there itself. Yeah.
Generally, we take y is equal to x as the model, right?
Y equals to
X. Like for example,
X?
even in case you took x, right? Y is equal to x. So like
No, you can take anything. Y equals to x. Just I took so that the calculation will be simpler. Yeah.
So if slope of line is given and one coordinate is given, how to find the other coordinate? Like which formula we have to use?
Okay. So if we have been given what? We have been given a straight line ka slope. Okay, slope is given m. What else is given?
The coordinate x and y coordinate of one point.
See, if this is a straight line, you already know the slope. 1 point you know. What else you need?
So the other coordinate.
There will be an infinite number of coordinate, right?
So like
if you have 2 points, then you can calculate. If you have x1, y1 and x2, y2, then you can calculate the slope of a straight line.
You can use the formula y2 minus y1 by x2 minus x1 equal to m.
No, but even then you can't, right?
No, then you
No,
can't
that is when
calculate.
that is if you use that formula, we get the equation of a line. We don't get a specific point.
Yeah, you'll not get because you can't calculate because you'll be having an infinite number of points, right, on the straight line.
That's right, sir.
Yeah, so that's why you'll not get. You can't get like, and this is not a valid question also. You'll get the straight line, the equation of the straight line you can get, but you can't get the other point because you'll be having an infinite number. If you have been given a square, if you have been given a what you can say, the equation of any like for example a circle, and then you have because there will be an infinite number of points on the circle, right?
Okay.
Correct? Sure. Yeah. So only if slope is given and 1 point is given, there is no point of asking the other point because there will be an infinite number of points. Okay, there can be a question which of the following options satisfy this equation. Like for example, you have been given a slope and then a point. So what's the you already know
there will be like in that question she would have missed, sir. They would have asked like something like if whether this point is lies in this line or not.
See,
We can ask
y2
something
there
like
is
that.
a okay. So there is a equation, right? You already aware of that equation.
Yeah.
So what is that equation that I wrote? The equation
A
of a
slope
straight
point
line.
equation or any of the equation we can use.
Yeah. So this was
Any
slope
of
you
the
were
formulas
already
we can
aware.
use. A point
So
slope.
you can so you can get the if you have been asked like slope is given and 1 point is given, 1 point is given, and then you have been 4 points can be given, 1 point, 2 point, 3 point, and then you have been asked which of the points will lie on this straight line with this
On the
slope equals
slide,
to n. That can be asked.
Yeah.
From there,
That is the question.
so that can be asked and that you can solve, right? You have a slope, you can put the value of the slope. You have a 1 point, right? Y1 and x1. You can put it and get the equation of a straight line, right? And then you can,
sir,
yeah.
Otherwise, you could just put the option inside, sir, and the line should equal to 0, sir, to be satisfy the condition.
This is what we are doing now. We are just finding out the straight line equation and then putting all the values.
Yeah.
Okay, sir.
Yeah.
Or we can even check the slope. That's it.
What?
Or we can even check the slopes, no? Whether
that
I mean, there are a lot of ways, sir.
So can you take one example?
See, I have a straight line y equals to. So you have been given like slope of the straight line is 1. Okay, and 1 point has been given. 1 point given as 1 1 itself, and then you have been asked which of the following 4 option is correct, like which of the following point is satisfying, is lying on this straight line. So how can you write the slope of, if you have been given the slope and 1 point, you can write the equation, right? How will you write? Y minus 1 equals to 1 x minus 1, correct?
Yeah.
So y equals to x is equation, correct? According to this, whatever the information I have, and then you have been asked which of the following points is satisfying, is lying on this straight line. So your option can be 2 3 3 4 3 3 4 4, right?
3 3 and 4 4.
Correct. So this from here you have to use the hit and trial method. Just put it on their straight line and see whether it's satisfying this equation or not.
Yes.
Yeah. So this type of problem will be asked in the exam. Okay.
So how to minimize the SSE?
Yeah, minimize this is I told you, no? If we have a formula, so
That
we
is
have
to-
2 3 lines you have been given, 1 2 3 4 line been given. You have to calculate the error for all and see for which of the following is the error is coming minimum. Okay, then only you can say this out of this 4, which one is the best fit line. Okay, got it?
Yes.
Yes, sir.
So this type of problem will be asked. So I'm telling you from week 1, I told you said this relation you have to divide it like which of the following equivalence, which of the following is transitive, which of the following this symmetric and then reflexive. Okay, and then function also similar type of questions will be there, which one is bijective, which one is onto function, which one is one function. And then from the second week you'll be having the most important is the SSE. You should be expecting some problem from the squared error, sum of a squared error, and then the straight line. So straight line, all the equation you should be aware of that. And then area of triangle, if this is coming to be 0, okay, you can have the data points and directly you should be aware of this. If you have 3 points, by seeing also somebody can, like, if the slope of both the line is same, then the area should be 0, right? So this type of problem you should be expecting from the week 2. Okay, and yeah, but yeah, so week 1 and 2 we are done. Week 3 and 4 we'll do in the next session. I don't know when is that session, maybe day after tomorrow.
Sure,
But
sir. Thank you, sir.
you have TA session, you can ask. Okay, so if you have if your session TA session is not there, yeah, next session we have again the 3 and 4 weeks. Whatever the doubt, try to solve all the mock. You have the solution also for the practice graded. Also, you have all the solution. Go through that. If you are finding a difficulty, you can just ask me on the discourse, right? Discussion forum is there. You can ask there.
Sir, in TA session they don't let us to connect.
Yes, sir.
They don't let us to
Connect.
So connect, sir.
They don't accept our joint request.
Yes. Right.
So day after tomorrow we have a open session. So are you going to take the rest of the 2 week in that session, sir?
Yeah, I'm not sure whether the revision session. Okay, if there is a session tomorrow, then the revision session will happen tomorrow itself.
Sir,
But
we
I
have
am not.
we have open session tomorrow as well as and day after tomorrow also.
Okay, so I need
Yes,
to
sir.
check.
Please try
Okay,
to take a class week 3 and week 4 also.
Sir, can you just please explain this SSE?
okay, I'll discuss it. Okay, so I'll discuss the SSE, but that will be our last topic for the today, and then we'll close. Okay, so what did you told tomorrow? I guess it's not the open session, that's a TA session. So I guess if you're not able to join,
And sir, straight line feet also, sir, with an example, sir.
so July tomorrow you don't have any session.
So we can take in the morning.
So 14th you have a
Sir,
session.
it shows a session is 10 to 6 to 10 on tomorrow for max.
But that is like TA session.
No, the TA session is a different one. Both the sessions are there.
No, it's like open session by TA.
What are
Okay.
TAs?
You can take the TA.
Sir, in the morning,
you are taking for 28th July.
Sir,
sir,
14th is the
take the
next
session
revision,
in the
sir.
morning.
Okay, so I'll just discuss the SSC part. Okay. This is sum of square error, right? Okay. So this is simply that you have to calculate the deviation that you are getting. The deviation that you are getting from the exact straight line earlier have been given. Let's for example, you have been given some square, like some function y equals to something like 2x plus 2. Okay. And this was the earlier defined function, defined straight line that was defined earlier. Okay. But the data point that you have got is different. So in the life, see, in our life cycle also, whenever, let's for example, you would have known about the this Ohm's law, right? Ohm's law, correct?
I
V
is equal
equals
to
to
V by
IR.
R.
V equals to I.
V equals to IR, right? And then in this Ohm's law also, this in the if you measure the exact volt, if you have some wire and then the wire should be having some resistance, okay? And then if you are that current is passing through that.
By sir.
If you are passing some current through that wire and then measuring the voltage, okay, V equal to IR is the ideal condition, right? So here also do y equals, let's for example, y equals to 2x plus 2 is some ideal condition for some model, okay? And from here we are putting the value of x and getting the value of y, simply similar to this Ohm's law. We are putting the value, we have the resistance, we are putting the value, this R can work as your slope, and I is some current that is passing through that wire, and then we are measuring the voltage. Okay, so similarly here 2x plus y, x is some variable, we are putting the value of x here, and then we are getting y. Okay, so this is some model has been defined earlier. Now, but this is the ideal condition, right? This is the ideal one, but we got some x and y. We got some data points, right? X and y in the form of x and y, some one, let's for example 1 2 3 4 5 6. Okay, so this is the data point that we have got in the reality. Okay, reality we have got x, according to this x we have got this y in the reality form, but from the ideal condition what should be the value of this y cap from this ideal condition 2x plus, we will put the value of x. If we'll put the value of x equals to 1, what we will be getting? 4, right? Similarly, if you'll put the value of x here, 3 into 2 is 6 plus 2 is 8. Similarly, 5 into 2 is 10 plus 2 is 12. Okay, and what is the deviation? You can see the deviation, right? So it should be 4 from the ideal condition, but we got it 2. Again, in the second condition, it should be 8, but we got 4. In the third one should be 12, we got 6. So what is the deviation that we are getting? So the deviation, how will you calculate that? As we are calculating a squared error, so we should be just doing the square. So 4 minus 2 ka whole square plus 8 minus 4 ka whole square plus 12 minus 6 ka whole square. Okay, and this is what the deviation chi square we are doing, and this is the sum of a squared error, because we are doing the sum of the squared error. Error is the deviation. Okay, is it clear?
Yes, sir.
Yes,
Very
sir.
Oh, I
Yes,
can't
sir.
put the mod only. Why we have to square that?
That is to,
What?
I mean, we are squaring it to avoid that negative syntax. That's it.
Yeah, but
Yeah,
we can put the mod now.
No,
we
no, no.
can put the mod also. See, we are reading what? We are reading sum of a squared error. Okay. So there are different
Squared, yeah.
types of, yeah. So we have a different types of measuring tools. We'll read it in upcoming like courses and all. So there are like n number of measuring this stuff. Okay. So here you are just reading the sum of the squared error. There is a reason behind that why we are doing this. One of the good like uh tools to measure the error. Why we are mostly penalizing it also. Let's for example, if we are getting some deviation from this was the straight line and this is the deviation that we have got. Okay, so we are penalizing that also. We are penalizing for that error also. Okay, we can do it with the mod also, but that mod we have been not taught. But there is some tools where you just measure the mod error also. That mod just calculate how much is the exact deviation. Okay,
Sir,
that is also a tool,
sir,
but that we are not reading it.
sir.
Yeah.
So, but if you take a mod, no, sir, it is only defined for some intervals, no, sir.
See, I'm telling you, there is a tools, that tool also, but here we are not reading that. That tool to calculate,
sir.
you directly calculate the direct deviation and then do the square or whatever you want to do. So there's, see, there is a method like mean of a squared error also, where you will be doing the
Yes,
mean.
sir.
Okay, but that we are not reading it. So why to discuss that? We are just discussing
Sir.
only one tool. Say it has been taught here, right? In your first, this is
Yes,
first
sir.
course, right? In the upcoming courses,
Sir,
will
we
be
can
taught
move
so
on,
many
sir.
things.
Ideal SSC is 0 now.
Huh. We are getting the squared that is 0. That's the best one.
And sir, less than 5 is
Less than 5 is the convention. If somebody has told like less than 10, that is also fine. Like the minimum, if you have like 10 models or 10 straight lines, whichever is the list giving you the list error is the best fit. Okay, is it fine to everyone?
Yes, sir. All well, sir. Fine.
Okay,
Thank you,
so
sir.
hope,
Thank
Okay,
you
sir.
very
Thank you,
much.
sir.
Thank you,
this
sir.
session would have helped you.
So
Okay,
thank you
let's
for
end.
the
So much,
patience.
sir.
Good night, sir.
Thank you so much,
Okay,
sir.
good
Thank
night.
you,
Good
sir.
night, everyone. We'll meet
Thank you,
in the
sir.
next
Thank you, sir.
session. Okay, thanks, everyone.
Sir, sorry for testing your patience.
Oh, okay, no worry.
Thanks for your wonderful patience, sir.
Yes, sir.
Thank you,
Thanks
sir.
for your patience.
Thanks.
Thank you,
Yes, sir.
sir.
Kudos to
Thank
your
you.
patience.
Good night, sir.
Good night, sir.
Good night. Good
Good
night,
night,
everyone.
sir.
Good night, sir.
Good night.
Good night, sir.
Thank you, sir.
Right.
Can anyone tell me was there any statistic session week 3 and 4 today?
Yes.
ये
Okay,
6 to 8 वही चल रहा था.
ये क्या वो YouTube में है क्या?
हाँ मिल
हाँ
जाएगा.
रिकॉर्डिंग होगी मिल जाएगा
नहीं वो तो मिल नहीं रहा था. I was not. अच्छा okay, I will find it.
Hi.
इंग्लिश की रिवीजन क्लास में होगी क्या?
Hello.